Well, hello there, this is Cool Dude Clem, and in this video I'm going to try to build a Tesla coil. Now most people know what that is. It's a coil of wire with a ball thing on the end and it shoots out bolts of lightning, and that's what I'm going to try to build today. Because most high voltage enthusiasts have built at least one of those at some point, and that's what I'm going to try and do. Now I think the first thing I'm going to do is actually work on the secondary, and this is what I'm going to do. I'm only going to start out small at first and build a small Spark-Gap type. Going to use this cardboard tube, and I've already marked out how long the coil should be. Might be able to see a mark at this end here. If we just turn the camera's light on, see a mark there and a mark on the other end, so I know where the coil should be, because the coil should be about 4 times as long as it is wide. And this is the wire that I'm going to use, just ordinary magnet wire. Now the difficult thing is going to be winding that wire onto the thing, but I'm pretty sure after that things will be pretty easy. I've already got a high voltage supply that I'm going to use. Not sure what kind of primary I'm going to use though. Don't know if I'm going to use a flat one or a conical shaped one, or one that goes up a little bit of the tube. Maybe I'll just experiment with different ones and see what works best. And I'm not going to do a top load on this right to start with, because if I don't get a little purple streamer off the end of this wire after a little bit of tinkering, I'll probably give up. But anyway, let's get started. This is the ZVS, which I'm sure you've already seen 1,000 times. We know the score. About 20,000 volts comes out of that flyback at goodness only knows what frequency, and only a few milliamps. But it should be enough to power the Tesla coil. And feelings for you, if you're watching this, I would just like to say I appreciate you being concerned for my safety, but there really is no need to worry, because I'm in full control of these things, and even though I did almost zap myself that one time, I always make sure that I am in complete control of everything before I do any of these experiments. One thing I've been curious about is what kind of effect a magnet would have on the arc, so let's just bring the camera in a bit closer. Okay, there we are, a bit of a crappy camera angle, but that should do. Now I'm just going to try this on low power. You can hear something crackling away. Let's see what happens. Oh, wow. Well, that's pretty cool. I think it's spinning round really, really fast. Don't know if that's interfering with the microphone or anything, but that is crazy. Let's just try to get a bit of a closer look at that spinning arc. Okay, power's on. I'll make sure this is in the camera shot. Listen to that iron wind. And smell that ozone. Wow. It's looking like something now. Took me a while to wind all this wire on, but basically now I've got a secondary or primary or whatever you want to call it. It's about 5.5 ohms, so I'm not exactly sure what kind of voltage, if anything, I'm going to get out of this, but it's certainly taking shape. Well, it's a little bit later on now, and I've made a primary, so it's sort of going to go together like that. Thought that would be the best type of primary to use. And I've started work on a high voltage capacitor. It's basically just a glass with foil wrapped around it and filled with salt water. Anyway, we're going to see what happens when I charge this quote-unquote capacitor with my flyback. And let's see, hopefully that it doesn't explode. Right, okay, power's on. Oh! I think we have us a capacitor. That's exactly the kind of arc I was expecting to get from it, but was not expecting it to arc over the edge like that. But that proves that it's working. I've just got to try and figure out what to do about that arcing over the edge, and then it should be just dandy. Saltwater capacitor number 2 is ready for testing. This one is just a Coke bottle filled with salt water with foil wrapped around the edge. No idea how well this is going to work. Let's see if it is even able to charge up. I can hear a lot of fizzing at the end of that wire. I think my Coke bottle cap is charged. And we didn't get any nasty arcing over the edge this time. I've absolutely no idea what the value of this is. It's probably somewhere in the picofarad range. Oh yeah, what a beauty! Let's just do that one more time from this angle so you can see it a little bit easier. I'm going to turn the power on. Okay, capacitor's charged. Now let's do a little discharge. Yeah. Okay, everything's built and it's ready to go. Got the flyback driver and the flyback there. Capacitor there, Spark-Gap there, and Tesla coil. I'm also powering this off a much smaller transformer because that other transformer is going to make that flyback produce more than 20,000 volts, and for a circuit like this really needs something between 6,000 and 12,000 volts. Also, I did make a little mistake with the coil. I said it's supposed to be 4 times as tall as it is wide, and that's actually supposed to be 6 times as tall. That might be a little bit of a problem. Also, there are only 340 turns on that coil, and ideally you need something like 750, or so I've heard. You may also notice that I'm stalling for time, because I'm absolutely, well, I don't know what's going to happen when I turn this thing on. Okay, let's try powering that up. Well, we have a spark. That's Spark-Gap, although you didn't see it. And I think I did see something at the end of that wire. We're going to dim the lights. Well, I'm going to turn the lights out. Camera probably can't see anything now. Right, I can plug it in. Yes, we do have a streamer at the end of the wire. It's very faint, but it's there. I don't know if you could hear me talking just then, but there was a streamer at the end of that wire. That's a good sign. Okay, we made the Spark-Gap just a little bit smaller, and we definitely seem to have voltage. Let me just plug this in. Watch your ear rolls, it's going to make some more noise. Definitely getting something from it. I'm actually quite impressed with the results I'm getting so far. I mean, I did not expect this thing to do anything. And the fact that it actually works pretty much the first time, yeah. And for some reason my spark gap seems to have shrunk. I don't know why, but those screws are a lot more closer together than they were when I started out a couple of minutes ago. There was about a couple of millimeters there, and it's now shrunk to almost nothing. I think maybe with a few less turns on the primary and a few more turns on the secondary, should get a pretty good Tesla coil done. At least I can still do the light bulb plasma globe thing. Yep, that's just an ordinary light bulb, but put 100,000 volts in it or so, and it does this.